Okay, before we solve quadratic inequalities, let me introduce you to something that's called critical values. Anytime we're dealing with inequalities, critical values, let me explain it like this. Critical values are where graphs can jump from below to above, or from less than to greater than, or they might jump from greater than to less than. So what we're going to do, before we start this problem, we're going to find what we call our critical values. And to find our critical values, pretty much we're going to set this equal, and we're going to solve it that way. So disregard the less than to begin with. We're going to move minus 18 by adding 18. We're going to move times 2 by dividing by 2. It gives me x squared equals 16. To get rid of a square, we do plus and minus the square root. That's my critical values. So the way we're going to solve these inequalities for now is we're going to graph our critical values. And again, that's where my answer could change, is somewhere at -4, at +4. That might be where we jump from less than to greater than, and so on and so forth. So what I'm going to do, where I move my 18 and my 2 over, I got x squared is less than 16. No, x squared, yes, is less than 16. Now what I'm going to do is I'm going to pick a point in each of my critical regions. Like maybe a -5 is somewhere over here. 0 is right in the middle. +5 is over here. I'm simply going to plug it in and see if it's a true statement. When I plug in -5 into this, I get 25 is less than 16. That's not true. When I plug a 0 into this, I get 0 is less than 16, which is true. When I plug a +5 into this, I get 25 is less than 16 again, which is not true. So here's how critical regions work. If 0 is a true statement and it's in this region, then every value in that region is also a solution. So my answer is all values from -4 to 4, not including -4, not including 4, because this is not or equal to. Let's work another one. So step number 1, we try to find our critical values. I'm going to go ahead and move my 3x squared over and combine it by subtracting. That gives me x squared. I'm going to move my I'm leaving my 12. I'm actually going to move my x over by doing minus x. I'm going to leave my 12. And again, I'm going to first find my critical values by setting it equal to 0. This one actually factors. Adds to give you -1, multiplies to give you -12, and -4 and a +3. My critical values are going to be x equals 4 and x equals -3. Again, we plot those critical values, -3 and 4. Make sure you put them in order like they're supposed to be. Pick a number from each region. 0 is always easy to plug in. -4 is over here, and +5 is over here. Any number in those regions. And we're going to test them. We're going to check them. So now I'm going to go back to where I moved everything over, and I'm going to put my greater than symbol back in. So x squared minus x minus 12 is greater than 0. When I plug in -4, I get 16 plus 4 minus 12 is greater than 0. That is 8 is greater than 0. That's true. When I plug in 0, I get -12 is greater than 0, which is not true. When I plug in 5, I get 25 minus 5, I get 20. I get 8 is greater than 0, which is also true, which means everything in this region works, everything in this region works, and what we called an OR statement before is what we've got now. My answer is all values from -infinity up to -3, or all values from 4 to infinity. And that's how you solve quadratic inequalities.